In this teaching session, we'll be talking about the alveolar gas equation, which is an important equation to be aware of. So the alveolar gas equation calculates the partial pressure of oxygen in the alveoli for a given inspired pressure of oxygen and also a given alveolar pressure of carbon dioxide. Now this represents the partial pressure of oxygen in the alveoli, and it's calculated using PiO2, which is the inspired oxygen partial pressure, minus PaCO2. So the capital A is in the alveoli, so this is the partial pressure of carbon dioxide in the alveoli over R. Now R is the respiratory quotient. Normally it's about 0.8, and to calculate R, the respiratory quotient, you do carbon dioxide production divided by oxygen consumption. You will learn as you do further reading that the 0.8 range varies according to your diet. So let's talk about how we calculate the PiO2, which is a partial pressure of inspired oxygen. So to calculate the partial pressure of oxygen, the equation that we have is PiO2 equals FiO2 times by P atmosphere, that's the partial pressure in the atmosphere, minus partial pressure of water, so PH2O. So PiO2 is the inspired partial pressure of oxygen, so this will be dependent by the FiO2. So for example, if it's at sea level, the FiO2 will be 0.21, and the atmospheric pressure would be 101, and the pressure of water vapour would be 6.3, and therefore giving us a PiO2 of 19.9 kilopascals. If you were in a high altitude, therefore your FiO2 would still be the same, your PH2O, so the partial pressure of water vapour, would still be the same, but what will change is your P atmospheric pressure, so this value. So in high altitude this would decrease, meaning that you get lower PiO2. So altitude. So this is why if you were to climb Mount Everest, there'll be less partial pressure of oxygen available for you, and therefore less alveolar oxygen available. So if we go back to the equation, so the other things that will affect your PaO2, so your alveolar partial pressure of oxygen, is your PaCO2. So the higher the PaCO2, the lower the PaO2 will be. And this is as part of the equation, because as you imagine, if this number is higher, this will be lower. The other thing that will be affect this equation is your R, so your respiratory quotient. So as I mentioned, it's affected by diet. So for normal purposes, we use a value of 0.8. But if the main substitutes in the diet is carbohydrate, then we would say this is a R value of 1. If it's a fat diet, it will have an R value of 0.7. So again, this would affect your PaO2 as well, depending on what value you give the R. So that's a quick brief overview of the alveolar gas equation.